Okay, so the topic for today I call databases for humanists, searching them and querying them. The first thing that we ask ourselves, or that I want to confront you with, is the question, what actually is a database? I'm pretty sure that every one of you has heard the word database, and everyone has used a database. But what actually is a database, and what is a database in a humanities context? That's what we're going to focus on today. I will tell you a bit about what kinds of databases you can find, what kinds of data we usually work with when we do humanities research, and I will show you 2 examples of very large humanities databases that we're going to do a couple of exercises with the next time we meet. So, what is a database? If you look at the picture, this is looks a bit weird, looks like a bit like the old card catalogs from libraries, but in a round shape. This is just a symbol for a database. Think about a database as some kind of a big container or a storage unit where you put all your data in. Now, it's true that you can store data in many different ways. For example, you can store data in text files, like when you write a document or so. They are relatively easy to create, text files, but they are very hard to search and especially hard to query. The other thing we can do to store our data is that we put our data in spreadsheets. If you think spreadsheets, think about something like Microsoft Excel, a big table with lots of rows and columns. Spreadsheets can handle small amounts of data, relatively good, and you can do simple analysis. But the more data you have in your spreadsheet and the more complex your analyses get, the more problems you will run into with the spreadsheet. It will not be able to handle that. And the third way, or one of the most sensible ways of storing your data, is actually storing it in a database. And the databases are very good for large amounts of data. Think about hundreds of thousands of records. And when you want to do complex analysis, then you want to use a database. So a database, we can say that in short, is the organized collection and storage of data of any kind. It doesn't matter what kind of data it is. And sometimes the database is also referred to as a data bank or data storage, or just short DB. You will find that relatively often. I have made 3 examples. So you see on the left-hand side data stored in a text file. This is a Microsoft Word document where someone wrote a bibliography, which is a list of texts they have used for their research. It's alphabetically sorted by author, last name, and then follows the title and so on and so forth. So this is a way that bibliographies or reference lists are very often done. It's a way of storing this kind of data, and it's accessible to a certain degree, but very hard to find something if you don't know that it already is there. Another example of data storage that could be very common for you to use is if you store a literary list or a bibliography in a spreadsheet. That's on the picture in the middle. It's not necessary that you see exactly what's on these pictures. It's probably programs you have worked with many times yourself. It's more to visualize the concept. What you can do with the spreadsheet is that you can chop your entries up in parts that have a certain significance. For example, you can have one column for the author name, one column for the publication year, and one column for the publisher, and so on and so forth. It would thus be much easier to retrieve some information. So if you want to sort how many books do I have from the 1980s in my research collection, or how many books do I have from the 18th century, and so on and so forth. That would work with this kind of spreadsheet, especially if you do not have an enormous amount of entries. Enormous amount would be something like 100,000 or even 10,000. That would be a large amount. So if you have 60 entries or maybe 120, the spreadsheet can handle that. That's not a problem. However, if we want to store larger amounts of data that are more complicated, then we would use a database. And on the picture on the right side of the screen is a screenshot of a bibliographical database called Zotero. I'm pretty sure many of you have used Zotero or are using Zotero or something alike. And what Zotero does is that it gives you the possibility to describe a bibliographical entrance according to a couple of categories that are predefined, and you can then do easy searches by typing something in a search field, or you can do very complex queries. These are some examples for a way to store data. However, we haven't talked about the actual databases yet. There is different types of databases. You could roughly say there is more or less two major types of databases, and the most common is something that we call a relational database or relational databases. They are based on a relational model of data, and that means the following. The data are organized in tables. Tables, you can think again of the spreadsheets. And each entry has a unique key that identifies the entry. And the rows, think again of the table, are sometimes also called records or tuples. So in the case that you run across these words, you know what they refer to. The columns in that table, they are called attributes, and they store information on each record. So what makes the relational database relational is that the rows in a table can be linked to other rows in other tables by using the primary key, the unique identifying key that you give to the record. And the relationships that you then have between the rows in the different tables are the logical connection between the tables and the data in the tables. The data in this kind of database can have three kinds of connections. It can have a one-to-one connection. One point is connected to another point. Or it can have a one-to-many connection. One point is connected to many points. It can also be the other way around. A many-to-one connection is also possible. And it can have a many-to-many connections. Many things in a table are connected to many things in other tables. This is the kind of relations you can create or you can visualize with a relational database. I have put on this slide a picture of a very easy relational database. On the left side, you see 4 tables. In the first table, that's on the top left side, you have information about persons. In the table below that, you have information about some geographical location. In the table on the bottom left side, you have information on some research sites that have been visited. And in the fourth table, which is the long column, on the right-hand side, you have some kind of survey data. I took these examples from an old expedition, geographical expedition. It doesn't really matter what the data is about. It's an example of tables in a relational database. And as you can see, each row has a unique identifier, or the so-called primary key, and then a number of attributes. So look at the first table. You have a little ID column, and there, for example, in the first row, you have in lowercase the word Dyer, and then you have as the attributes in the columns the first name, which is William, and the family name, which is Dyer. So you have here a description of a person name with an ID. And if you take a closer look, you will see that table 3, for example, that lists the locations where research has been conducted, uses the primary keys of table 2, which is the geolocation of different research sites. And table 4 uses the primary keys from tables 1, the table that describes persons, and table 3, the table that describes the research locations, to connect the data. So what you have here is that the information or the data in the database is connected by use of the primary keys in different tables. This connection or this relation makes it a relational database in a way. So what to do with the data in the database? Usually what we want to do is we want to analyze the data. We don't just want to store it. It's a bit pointless if we have put it somewhere and then we forget about it. So we want to access the data again. We want to retrieve information from it. So if we want to do that, then we have to write a query. The term query, at least in computer science, means that you want to do a precise request for information retrieval, usually in a database. So, precise request for information retrieval. That's what we call a query. And the query language, you can think about it a bit like a programming language, so the query language that we are using for retrieving this information is called SQL. SQL, that means structured query language. So, for example, with our 4 tables and our data sets, what if we want to display the names of the researchers in table 1? We could write it in SQL the following way. We would write in capital letters, select. Then we write family, which is the attribute in the 3rd column of table 1. We write a comma because we want to chain a couple of commands. And then we write personal, which is the 2nd attribute in the 1st table. We write in uppercase letter from, and then the name of the table we want to take the data out. So basically what we have written is, or what we have queried the database is, give me the family name and the first name of all the people that are listed in the table called person. And if we enter this command, it will actually retrieve the names that are stored in that table in the order of family name first and first name last. If you take a look at the table on the upper left side, it is stored the other way around. So the order we want to get, we have to write it in the query. However, there is not just relational databases. Up until the early 2000s, relational databases have been the single most common databases that are there. And until today, they are still what is mainly used and what you might encounter in everyday life. For example, the information in your bank account that your bank is hosting is a big relational database. However, humanists or human artifacts, records about them, they are what we often call messy data. They are a bit hard to store in these kinds of tables, and it's a bit hard to already know all the attributes we might be interested in and all the kinds of relations that these different records could have with each other. So, since the early 2000s, roughly speaking, more and more data, and especially humanistic data, think about texts, images, music, or something abstract like philosophical concepts or something like that, have been collected and stored in so-called graph databases. And the underlying idea of a graph database is that the data are connected in a network of so-called nodes and edges and properties. So, now what's that? Nodes represent entities. For example, people, or books, or paintings, or stones, or whatever. And they are, in a way, a bit like the records. Think about our rows in the relational databases. And then you have edges. And the edges in the graph database, they represent the relationships that connect the nodes to each other. So an edge could be, or the relationship the edge describes could be something like, is a friend of, is the father of, is married to, or in the case of books, is printed by, is published in. So the edge is a relationship. And edges are, unlike the relations in relational databases, even though they have it in their name. They are the key concepts in graph databases. That's what the people are most interested in, is the relationships. And then we have as a third concept the properties. And properties in a graph database, they contain relevant information to the nodes. And as an example, let's say cat. The word cat is a node. And properties to that could be, for example, animal. Cat is an animal, part of the family of animals. Or another property could be pet. There's numbers of pets, and cats are commonly pets. But it could also be something like a word that starts with C. So you see that the properties are of very many kinds and facets, and not necessarily something you would be able to put easily in a relational database. This is a picture that is supposed to visualize the idea behind the graph database. You see on the left side and on the upper right side, you see nodes. And these nodes have entities. In this case, it's Bob and Alice. And on the lower right side, you have, in the slightly red colored bulb, you have properties. And the property of both Alice and Bob is that they are in a group, apparently a group of chess players. And what the arrows between these different nodes describe is the relation. That's what the graph database is most interesting for. For example, in this picture, it is the black arrows that say no. So the relationship between Bob and Alice is they know each other. And the relationship that we have between Alice and the property of being part of a chess group is that she is a member. And as you can also see, the arrows go both ways. So not only is the node defined by the relationship to the property, but also the other way around. And now for something more practical. Europeana collections I'm not sure if you have heard of that. If you haven't heard of that, it's definitely worth checking out. Europeana is a digital platform that aggregates cultural heritage collections of thousands of European archives, museums, and libraries, and other cultural heritage institutions. And with the Europeana platform, you have access to more than 50 million digitized items, and that can be anything from books or manuscripts or pieces of music or sheet music, art pieces, but also everyday objects, photographs, garments, anything. The Europeana also has curated thematic collections, and most famously the lately finished collection on World War I. Europeana is and stays free and open access, and it is available as of a couple years ago in 27 different languages, European languages that is. And the Europeana allows for various search functions, but also for various query functions. So, how do we get material from Europeana collections when we want to gather material as humanities students, as master students in European culture? For example, what we could do is that we could do a simple search. If we click on the link, the Europeana portal will open, and what we see is something that looks very familiar. It is a little search bar that works almost like Google. And we can come up with an interesting search term. For example, we want to find out something about, let's say, something about fashion, so we look for boots. And when we click enter, we will get a large amount of hits from different institutions that have an item in their collection that is described with the word boots. It can be a picture of boots, it can be a text about boots, it can be actual boots as 3D objects. The search function on Europeana is something I don't need to introduce to you much, because you will have seen that. It looks basically like a library catalog, works very easy, very intuitively. You can also chain boots, you can chain search strings. For example, you want to say, yeah, I'm interested in boots, but I want only Italian things. So, for example, what we can find here is actually a 3D scan of Roman boots from an Italian institution. And what happens when you click on some of the items is that you will be directed to the actual institution that has this item in their collection. So you will be directed outside of Europeana. However, that's not what we want to do in this class. So the point with databases and knowing how to use this is we want to go beyond a simple string search. We want to go beyond accessing material that way. And we can do that. If we write a query instead. So if you think back about the relational databases and where I showed you how to do an SQL search, you can also do that with this kind of database. And interestingly, the Europeana is a graph database. So we will not be helped by our SQL search terms. We have to do something else. So how do you query graph databases like the Europeana? We have to use a different language, and this language is called Sparkle. And Sparkle is a very badly chosen acronym, and it stands for Sparkle Protocol and RDF Query Language, which doesn't tell us much unless we know what RDF stands for, which is Resource Description Framework. And this is a metadata data model. We will not go into what that means. It is more or less for you to keep in mind. So if we want to query the Europeana with a query language, we can go to a link that is called sparkle.europeana.eu. And this will give us a front end. So this looks a bit different than what we have seen before. This does not look like a simple search and hit enter. What we have to do here is that we have to write a little query in Sparkle, and I have prepared a little query, and we will add it in this front end. The query is about, give me all institutions that have contributed to the Europeana collections. If we click on Run Query, we will get a not very pretty looking long list of all the data providers, so all the institutions that have provided content to Europeana. You can scroll through that list, but it will take you a couple of minutes because it's so long. Keep in mind, 50 million records. And that's also a lot of institutions. The point being that very much like the relational database, which can be queried and the information can be retrieved with SQL as a query language, we can retrieve information from graph databases, for example from Europeana, by using Sparkle as the querying language. You can do, by the way, exactly the same with Wikidata, which is another freely available resource for humanistic data, and has over 45 million data items and is accessible in 290 languages. And like Europeana, Wikidata has also its own query service, the Wikidata API. You can go to query.wikidata.org and write your Sparkle request there. What we will do in the next seminar is that I will show you how to write Sparkle queries in both the Europeana API and the Wikidata API. And I will do that by live programming so that you can immediately follow along and execute your own queries. And we will be using both Europeana and Wikidata. I will, though, try to use mostly Wikidata because they have more examples and it's more fun to query that. In order to prepare for the next seminar, I would ask you to check out the following two links in order to read a bit on how to Sparkle. But keep in mind, you're not supposed to become a database programmer or someone who professionally queries databases. This is more so that you get some idea of what it means to use a querying language. So don't worry, get accustomed, and then we will meet again in 2 weeks.